Hello everyone. I'm 始まってない。I'm Yuta Iwamoto. I chose the topic of tomato harvesting. Now let's start. This is outline of my presentation. First, I talk about tomato harvesting robot, and second, principle and structure. Third, issues for realization, and fourth, tomato harvesting robot competition in Japan. And last, I talk conclusion. First, I'll introduce the tomato harvesting robot. In the present, many people have been developing agricultural robots for increasing efficiency and decreasing cost. And about tomato too, many studies are going forward. Now, tomato harvesting robot has been developing, but it isn't practical yet. In Japan, it's mainly researched by Shimane University and Osaka Prefecture University. After the research has done, the robot like this picture may work instead of human in the future. Next, I'll talk about fundamental structure of harvesting robot. The 3D vision sensor is used on the harvesting robot, and it scans fruits using a laser beam. Having two different wavelengths to measure the 3D shape as well as to distinguish foliage and immature fruit from red ripe fruit. It uses cold filter, to overlay a near-infrared beam and a red laser beam. The light reflected by an object passes through a lens and forms an image on the photosensitive surface of the PSD. PSD is a position-sensitive device. The distance is calculated by triangulation based on current ratio between two anodes. So we can calculate the distance using triangulation. The emitted laser beam is blinking and the receiver unit extracts only the blinking wavelength components, distinguishing them from the fixed light of the sun. When a laser beam with two different wavelengths is emitted, the PSD receives the light component of both wavelengths. The near-infrared and red laser beams blink at different frequencies. As shown in this figure, foliage and fruits all reflect the near-infrared laser beam well, but foliage and immature fruits have a low red laser beam reflectance. Red fruits are detected by the 3D image processing program based on this principle. This figure shows an example of the 3D vision sensor, which scans with near-infrared and red laser beams. This unit is being used in research for multifunctional robot for tomato cultivation, which trains vines and defoliates as well as harvesting. The 3D vision sensor is attached to the end of the arm. On its own, the sensor is capable only of vertical scanning. Next, I'll show the result of the image processing. Cherry tomato fruits grow in clusters as shown in the left figure. The center figure is a representation of pixels of the object located within a certain range. Based on voltage differentials between the near-infrared and red light signals, pixels with greater and red values are shown as a white, and all others are shown gray. Third, I'll talk about issues for realization. Many issues to be resolved. 1. Work in narrow field. The field is crowded with fruits and stocks. They have to recognize the complex field and change light condition. They recognize the fruits by unreflected light, but when the field is little dark or well lighted, they have to do their jobs as usual. And tomatoes with different positions and orientations. If a tomato is hidden by other tomatoes or stalks, they have to find and harvest it. And harvest with calyx intact. It is not necessary, but when it's put on sale, it seems better. Harvest without damage, especially cuts and scratches. That's the same reason. And last, autonomous. It is difficult to be solved, but it's necessary for amount harvesting. Competition to encourage practical development and solve the issues, Kyushu Institute of Technology holds the competition this year. They should seek the development of collecting many ideas. And this is conclusion. Further development and innovation will be from many people, including tomato farmers. After the tomato robot becomes practical, the next step will be a free autonomous plant factory. At the end of my presentation, I want to talk about why I chose this topic. My home prefecture is Kumamoto Prefecture, and it is the biggest tomato producer in Japan. So if tomato harvesting becomes autonomous, my prefecture will profit. And in the future, I want to work for my hometown. So I chose this topic because it may give me some hints. That's all for my presentation. Thank you for your attention.
Are there any questions? Now's your time.
Thank you for your presentation. During the harvesting of tomatoes, sometimes there tends to be cluttering together of tomatoes so that you can find some tomatoes are hidden behind other tomatoes. So how do you take good images to ensure that when training maybe the algorithm or the robot, you are able to get even the hidden tomatoes, like sometimes there is one tomato here, another tomato behind it. So how are you able to get good images or good imaging positions so that you can be able to pick out all the tomatoes using the robot? Thank you.
I think before harvesting, the robot sees the tomatoes image, and after the harvesting, the robot have to check that all tomato is completely harvested. That's maybe that solves the problem, I think.
Thank you. Any other question? Question?
I strongly suggest you don't delete the okay. Just deleting is not obvious kind of the makers understand well. So should keep in your mind and you may carefully pointing on the PowerPoint and explain some of the features or some of the another very important thing to present.
Are there any questions in TU?
Thank you for the presentation. And I have a question that how long does the robot take how long does the robot take to catch the tomato? And can the robot catch the different size of the tomato, the big size and the smaller? Thank you.
You mean how can the robot catch different size tomatoes? Or
First question is, how long does it take the robot to identify and then pick tomato? How many seconds? How many minutes?
it's not long distance because it recognizes a tomato by some ranges that
The question is how long it takes to harvest 30 seconds or 1 minute or more time necessary?
a long time. I didn't see any movies of this robot, so I don't know the times to harvest.
Second question. There's a big one and there's a small one. Can the robot harvest different size fruit?
So it is so end effective program. So if we use so changeable end effect, we can take any size of tomato, I think.
Does that answer your question?
Okay, thank you. No questions and comments from Taiwan.
Okay, thank you.